All right, welcome to section 1.3 in the algebra curriculum. This is part 1 of 2 for this section. So today is going to be half of a section, and then in the next lesson we'll cover the other half of this section. So today it's going to be solving equations with variables on both sides of an equation, and it's going to look, here's an example, it's going to look something like this. So we have variables on both sides of the equation, and we're asked to solve. And again, to solve means to get the variable. In this case, we only have x's, so get x by itself. All right, so if we're going to solve this equation, we need to get x by itself. So right now we need to get x's onto one side and then get all the numbers to the other side, because again, our goal is to get x by itself. So how do I get a positive 4x to the other side? I've got two x's on this side, so I'm trying to get this 4x to be on the same side of this equal sign. So the equal sign's like a little boundary. We're trying to get that 4x on the other side of the boundary so that all the x's are on one side of this equation. So how do I move a positive 4x to the other side of the equation? Or in other words, what do I have to do to this right-hand side to make that 4x cancel out and just equal to 0? Well, 4x minus 4x is 0, so I want to subtract 4x from both sides of this equation, because again, 4x minus 4x is 0, so that eliminates it from the right-hand side of the equation. So I'm using that subtraction property of equality to move it to the other side of the equation. All right, so if we look at this left-hand side, what we end up with is negative x plus 2x minus 9 minus 4x. Well, we've got a bunch of like terms. We have a bunch of different x's on one side. So let's combine all of those like terms. So on this step here, I'm going to combine like terms. Combine like terms. So all of the x's can be combined together. So I'm going to combine negative x plus 2x. So negative 1x plus 2x, or in other words, 2x minus 1x is 1x. So these two added together give me 1x. And then I still have minus 4x. So 1x minus 4x is negative 3x. I still have that minus 9. And it still equals now just a 6. All right, so did I get x by itself yet? Well, no, because I still have all these other values around the x, so I still need to move those values to the other side of the equation. So like in the last lesson, we are trying to get the term with the variable in it, in this case with the x in it, by itself before we take care of whatever's before the x, called the coefficient. So we need to get rid of this minus 9 first to get that term with the variable in it by itself. So how do I undo subtracting 9, or what would make that minus 9 a 0? Well, if I add 9 to it. So the inverse operation of subtraction is addition, so I'm going to add 9 to both sides of this equation using that addition property of equality. These cancel out. I'm left with negative 3x, my equal sign, and 6 plus 9 is 15. All right, next up, I need to undo multiplication. So the inverse operation of multiplication is division, so I'm going to divide both sides by negative 3. And that will give me negative 3 divided by negative 3 is a 1, so these will cancel each other out, and I'm just left with 1x, or x, my equal sign, and 15 divided by negative 3 is negative 5, and that is my answer. I know this is my answer because, again, I need to just solve, which means get x by itself, and x is all by its lonesome self over here, so that is my answer. X equals negative 5. All right, 3 more examples to go. They'll go by pretty quick. So here we've got a fraction, but that's okay. A number outside of parentheses, to get that into the parentheses, we need to use the distributive property. So same thing over here. I've got parentheses, value outside of parentheses. I can distribute in that value. So I'm just going to type that out in here for those of you that still have paper copies. We're using use the distributive property. Make that a little bit smaller here. Love this picture. All right, here we go. So multiply in these values, use that distributive property. So negative 2/3, I'll just write this out. Negative 2/3 times 3, or times 3 over 1. You can write any value divided by 1 and it's still itself. Minus, oh, wait a second, a negative times a negative is a positive. So those negatives cancel each other out. And then we have 2/3 times 6 over 1 times x. And it still has an equal sign, so carry that down. Negative 3 times 8x is negative 24x. A negative times a negative, again, is a positive, and 3 times 4 is 12. So that's what this equation becomes. So now if you look at this, this isn't so bad. Yes, it's a fraction, but what is 3 divided by 3? 3 divided by 3 is just a 1, so these 3's cancel each other out. Here you've got a 6 divided by 3. What is 6 divided by 3? Well, that's just a 2, so this turns into a 2, because 6 divided by 3 is 2. So now the expression just becomes negative 2. Negative 2 over 1 is just negative 2, plus 2x, oh, sorry, 2 times 2 is 4. I missed my 2 up here. 2 times 2 is 4, so I have 4x, my equal sign, and then copy down that right-hand expression there, negative 24x plus 12. So now it doesn't look so bad. It looked pretty nasty right away, then even worse in the next step, but then we got rid of all those fractions, and it just becomes this. All right, so let's go ahead and just like the last one, since we have to solve, it means get x by itself. So we need to get all the x's to one side, all the numbers to the other, and then get x by itself. So I'm going to add 24x to both sides, because adding 24x to both sides will turn this into a 0, ultimately eliminating the x's from the right-hand side. So I have negative 2 plus, combine these like terms, you get a 28x equals 12. All right, x is not by itself yet, so I'm not done. I need to get that 2 out of there. So how do I get a negative 2 to the other side? Well, I need to add 2 to turn that into a 0. So add 2 to both sides. That addition property of equality will cancel this out. I get 28x equals 12 plus 2. 12 plus 2 is 14. And the last step to get x by itself, the inverse operation of multiplication, because we're multiplying by 28, is division. So divide by 28 on both sides. That will cancel out 20, the 28ths, excuse me. So we get x equals 14/28, which is 1/2. If you simplify 14/28, it is 1/2. So that is my answer. X equals 1/2. All right, just 2 more examples to go. So on this one, this was one of my favorite shows when I was a kid. I don't know if any of you know what this is from, Inspector Gadget, but anyway, it says write and solve an equation to find the mystery number. So we're trying to find a mystery number. It says a math word right away, the sum. The sum, again, is the result when you add. So the sum of twice of the mystery number. Well, let's just call this mystery number a variable because we don't know it. So let's say the mystery number is x. So it says the sum of twice of this x and 20 is 83 minus, again, that mystery number minus x. So it says write and solve an equation. So we know we have to write and solve an equation, but it wouldn't really have to say that because I see this word is. The word is in math represents an equal sign. So the sum, we're going to add 2 times x, twice of x means 2x. We're going to add 2x and 20, so 2x plus 20. That's what it means when it says the sum of twice the mystery number and 20, the sum of 2x and 20, so 2x plus 20 is, so equals 83 minus that mystery number, minus x. So the sum of twice the mystery number and 20 is 83 minus the mystery number. All right, so now we need to solve this equation. So now it's not so bad. We need to get all the x's to one side, all the numbers to the other. So I have a subtraction here. I need to undo subtraction. The inverse operation of subtraction is addition. So I need to add x to both sides. That will eliminate the x's on the right-hand side. And then I end up with my like terms, 2x and x. I can add those together. So I get 3x. I still have a plus 20 on the left-hand side. Equals 83. And again, I need to get the term with the variable in it by itself before I can divide off that 3. So let's get that 20 out of there. So I'm going to subtract off 20 from both sides of my equation, eliminating the 20. And then I end up with 3x equals 83 minus 20 is 63. And divide both sides by 3. The inverse operation of multiplication is division, so we're dividing by 3 to cancel out the 3. We get x equals 21, and that is the mystery number 21. So just to double check this, the sum of twice this mystery number and 20. So if I take twice of this number, I get 42, and add 20, I get 62. It says that is 83 minus that mystery number. Is 83 minus 21? Well, what is 83 minus 21? That is 63. 2. So I end up getting 62 when I take the sum of twice of this number and 20. So again, 42 plus 20 is 62. Or if I take 83 minus 21, I also get 62. So that is the mystery number. All right, one last example to go. Looking at a little pizza here. I always thought that looked like a little table, so I love this picture here. It says, write and solve an equation to find the number of toppings for which you would pay the same amount for pizza A and pizza B. So we have a little chart here. We're at a pizza place. We're picking out some toppings. We see for pizza A, this option here, it says the cheese pizza is $8, and then we're going to keep adding toppings for $1.25. Whereas pizza B is $11.25, but the price per topping is only $1. So a couple of options. So on pizza A, it says the price per topping. Again, we see that word per. That's a key word that tells me that I'm going to be multiplying this by X because every topping is another $1.25. So if I have 5 toppings, I do 5 times 125, 1.25. If I've got 7 toppings, I do 7 times 1.25. So I need 1.25 times X. The base price of this pizza is just $8. So this is a one-time fee of $8. So for pizza A, I've got $8. And I'm going to add on $1.25, but not just one time. It's however many toppings I get, that's how many times I must add on this $1.25, so I put 1.25x. So this is the cost of pizza A. Now, since I used a variable, I should define my variable, so x is defined as the number of toppings, number of toppings. Number of toppings. All right, so that's pizza A, the cost of pizza A. And it says, write and solve an equation to find the number of toppings for which you would pay the same amount. That means the cost of pizza A equals the cost of pizza B. So the same amount, I'm actually going to write that on here. The same amount means the cost of pizza A equals the cost of pizza B. Again, please be patient with me. I'm writing with a mouse. All right. So again, the same cost implies that these are equivalent to one another. That's the same cost for pizza A and pizza B. All right, so there's my cost of pizza A, and it must equal the cost of pizza B. Well, what's the cost of pizza B? Well, we have $11.25 as our base cost, and then we're adding on $1 per topping, so we're adding on 1x, or you can just put x. I'll throw 1x on there for now. All right, so every topping is another dollar. So if I have 5 toppings, I gotta add $5. All right, so I need to solve this equation to find the value of x, the number of toppings that would make them cost the same amount. So just like the last 3 problems, I need to get the numbers to one side, the variables to the other, and then I can solve for x, because again, solving means get the variable by itself. So what I'm going to do is get x's to one side first. I'm going to undo addition using the inverse operation, which is subtraction. So I'm going to subtract 1x from both sides of the equation. That will cancel out these x's on the right side, and I end up with 8 plus 1.25x minus 1x is 0.25x. That equals 11.25, 11.25. And then again, I need to get the term with the variable in it by itself before I can divide off that 0.25. So I need to get rid of this 8. So how do I make this 8 into a 0? Well, I need to subtract 8. So I'm going to do the same thing to both sides of my equation, so it remains true. Subtraction property of equality. And I get 0.25x by itself on the left side of the equation, and on the right side, 11.25 minus 8 is 3.25. All right, and then lastly, I need to undo multiplication by dividing off that 0.25, and that will get me to my answer. So I have x left over by itself equals 3.25 divided by 25. Think money. There are 4 quarters in every dollar. I've got $3, so that's 12 quarters, and then one more is 13. So x equals 13 is the solution. Now, because this is a word problem, I'm not just going to leave my answer as x equals 13. I need a label. So x equals 13 what? Well, I already defined x up here, so this makes the label pretty easy to figure out. X is the number of toppings, so 13 toppings. 13 toppings. And again, because it is a word problem, I should write a sentence. So let's just say the number of, actually, pizza A and pizza B will cost the same amount if you purchase 13 toppings on each pizza. And there we go. That is officially my answer in sentence form. All right, so your assignment is 1.3 Practice B. That is a worksheet that I will post on Google Classroom. You have to do problems 1 through 8 and then 13 through 16. However, number 16 is worth 1 point of extra credit. And then for numbers 14 and 15, you will have to know some equations that you probably haven't seen in a while, or maybe you've never seen them before. But the surface area of a cylinder is right here, and the volume of a cylinder is right there. Don't get too hung up on these equations, and if you've never seen them before, don't freak out. It's okay. Just read through the problems. Ultimately, you're just plugging in different numbers, and then you're going to solve for a variable. But just plug in different numbers and then go from there and try your best on those 14 and 15. But I'll be looking for your submissions on Google Classroom. Try your best. Thank you.